Hi everyone. Today I'm going to start basics of complex number. So we have to learn about the complex number. So why complex numbers is important, and when we actually the first time complex number introduced. So actually we know that if you have like a expression x square plus 1 equal to 0, and you want to find the x to satisfy this equation. So you know there is a real value is not a possible. There is no such a value for x. We will get the zero here. And one more concept. Suppose if you want to find the here square root of this one. Suppose x square can you write minus one, and x becomes square root of minus one. So we know that inside the square root always going to be a positive number, but here we have minus one. So square root of minus one is not a possible in a real case. So first time Euler's is introduced one notation. Euler's introduced means gave one notation that is called iota. So here, what the meaning of iota? X equal to here minus one. Suppose we have a I square, and iota is given by Euler's, and this is denoted by I. Okay, this I is nothing but minus square root of minus one. If we square both sides, you will get I square is the minus. So this I is a complex, basically. This I is a complex number. Similarly, if you want to find the square root of like we have a minus 4 and a square root of 4. So 4 we can find here. We have a square root of 2. But here we can't find. So again, you can use the same concept here. Minus 4 we can write minus 1 into 4, and minus 1's, yes, already we have that I square, iota I square into 4. That is equal to 2 into iota. We got here. Okay. So here I is the iota is the complex number. We can say I or iota generally we here pronounce yes that iota. Okay. So now the concept is came from this point. Once uh, complex number you got the concept, then we have some property of this concept. What is the main properties of the text page? Suppose we have a I square is a minus one, iota square is a minus one. Suppose we are going to find the value of I to the power what we get. So we get I square into I square. So minus one into minus. Okay. So I to the power for what we are getting 1. Similarly, if you are going to find the value of here we have I power 6. What is the value? So we can write I square into I square into I square. Okay. So here I of power 6 is iota 6 is equal to, we'll get here minus 1 into minus 1 into minus 1. That is equal to. So what we are getting here I to the power 6. And similarly, if you find I to the power 8, we'll get plus 1. Can you say I power 4 we have 1, so I power 8 is also. So based on that, what we get here one concept here. The concept is iota to the power 4n will be the 1. We can check by putting n 0. I power 0 is 1. And 1 I to the 4 1. We can put also. This is a general value. If you have like that iota power, then you'll get always 1. Similarly, if you're going to find the value I6, we are getting minus 1. Before that, already we find the value I square is the minus 1. So we can see the difference between these two terms is a 4. So next, suppose we have I to the power 10. What will get again minus 1? How? We can write here. I power 10, we can write I power 8 into I power 2. That is iota, we can say. Iota power 8, iota power. As we know that iota power 4, iota power 8 can be write iota power 4 power 2 into iota square. So this I values, we know that plus 1. I power 4 is the one, we know that. We have a formula. Already we studied this one. So 1 to the power 2 into minus 1. So we'll get minus 1. So I power 10 we are getting minus 1. So what we are getting on series we can see I power 2, I power 6, I power 10, I power 14 dot 30 will get the minus 1. All this value going to provide a minus 1. So we can write the general value for this one is I to the power 4n minus 2. Where n is this value here. This value is becomes minus. This value becomes minus. So where n is 1, 2, 3. We can write plus 1 also, but your n is to be start from. For n plus 2, we can write here, but your n will be going to be start from. Either you can this one or this. So this value becomes minus 1. So we can check. 1 I square minus 1. 2, 2 into 4 minus 8, 2 into 4 into 8, 8 minus 2 is 6, I power 6 minus. Similarly, if you are going to put in 3, so 3 into 4, 12 minus 2 is 10, I power 10 the minus. So this basic general formula we are getting, if we have like that, then we'll get a minus. The same concept we can apply to calculate some value of power, whatever I values here that can use. Okay. Suppose we have I power, we have 98. Suppose we have a 98. We have to get the value here. So what we have to do first, the concept is very simple concept. First we take in this one. Multiplication of 4 odd terms. Right? So we know that if you're going to divide by 498, not going to divide, but we can write this one 96 in I power. 96 is divided by 4. We can divide 96 by 4, we will get 16. So we can write 6 I to the power 4 power 16 will 96. Okay. And also we can do this here. 1 minute. Let me correct this one. 16 we'll get here. A very simple way we can get that why should we use this kind of things. We know that we can divide by 2 also. I square is a minus 1, so we can divide here 2 by 2. So I square we can write power here you can write 49. Correct? Yeah. And you know that I square is a minus 1 or 49. That will be minus 1. We know that. So I to the power 98 becomes minus 1. So this way you can find whatever we have given for we can use to calculate this. Okay. Similarly, suppose here we have I to the power 3. What you will get? So I power 3 is I square into I. So I square is a minus 1 into I, that is becomes minus. Similarly, if you are going to calculate I power 7, what you will get? Is I power 6 into I. I power 6 is the minus 1. Know that? So I becomes minus 5. So we can see previous case also I square is a minus 1, I6 is the minus 1 we are getting. So difference is 2 here, sorry 4. Every terms we have a difference is 4. Even I power 4 is the one, I power 8 is the one, I power 12 is the one. There also we have difference is 4. We can check here. This one we can use I power 4, I power 8, I power 12, I power 16. We will get the one. So what the difference is? Difference is 4 here. So here also we can get the difference 4. After we have I power 7. So next we get 11. That value also becomes minus I. So we are getting a series here. What we are getting? 3, 7, 11, so on. That is I power all this. This is a coefficient. This is the power we have. Okay. So if you use the series concept here, if you want to find the general value for getting minus I, we can write the very simple way. I to the power first term we have a, we can say 3 and difference is 4. We can say difference is 4. So we can write a very simple way 4n minus 1. If you put n1, we'll get I power 3. This is minus I. If you put it 2 here, you will get 8 minus 1 is 7. Already we have a minus I. If you put a 3, you will get 11. So on. This is a general formula to get minus I. Okay. So these are the basic concept here regarding the complex number means iota, the power of iota, what will get the different cases. I'm going to discuss basic concept questions here also. Before that, I'm going to explain representation of complex number because we use the iota here. Iota is a complex number. How we are going to represent a number, any number in complex form. So, very simple way. Representations we can write or complex number is a plus iota b. Or we can see other books we have given like x plus I y like that. So what the meaning? A and b are the coefficients. So a we can say is the real part and b is the imaginary part. Imaginary part. Okay, and iota is the complex number. You know, this is nothing but is a complex number. Iota is a complex number. Know that. Now the concept is what is the complex number? We learn here complex number like iota is to represent number in form of complex. But what is the meaning? So basically its name is a complex number, but it's not a number. It's a point. Complex number is a point in a Z plane. Suppose here we have a x and here we have a y. If you have any point here and we are representing this point in complex form. So what we have to get? We have to get the positions and the uh, position vector and theta value. So basically complex number is just like a point in a complex plane. This is plane is suppose xy plane is a complex plane. So we are going to use a point that is called the complex number that we are representing this. So now I'm going to explain some basic questions here. Later I'll extend this theory. Questions we have. Suppose we have to get the value of 1 plus iota power 2. What will the value for this? You want to calculate. So nothing to do. Just expand this value. We know that a plus b whole square formula we have. So we can write a 1 square plus iota square plus 2 into 1 into iota. So here 1 iota is a minus 1 and 2 into iota. So 1 plus minus 1 cancels. Here you will get finally we will get the 2 into iota, 2 into I. This value for this one, 1 plus I power whole square. Similarly, we have another examples also. Can use here. Suppose we have a complex numbers. Generally, we are representing in form of Z that let it have a suppose here we have a Z, you can say, or Z here also we can use. So complex number we have a given, and that value we have a given like suppose 1 plus iota, and we have to calculate the value of Z square like suppose with it. So we can write here 1 plus iota power 2, or we get this value 2 1 just multiply with the conjugate. Okay, if you multiply by conjugate, what will get minus I and 1 minus iota power. Okay, so what we get here 1 minus iota power 2 divided by, if you expand this value, we get 1 plus iota square minus 2 iota by. These two cancel, 2 cancel, we get minus. So what we are getting Z square value is we are getting minus. Sorry, minus I. we are getting minus. Okay, suppose we have a given this state is 1 by 1 plus iota, but actually it's not of complete complex numbers form. Why? Because here we don't have a real line. So what we have to do in this kind of cases, just multiply with the conjugate, numerator and then we can find the complex number value. What will get your 1 minus iota, 1 minus iota square. It will be equal to 1 minus iota divided by 1 plus 1. That is 1 by 2 minus iota into 1 by. Now this is the complex number form. Here we can say real part we have a 1 by 2 and imaginary part also we have. Also we have 1 by 2. Both. So this way we can represent the complex. So in next class, I'll start some more concept here. Today I'm going to wind up this one.